Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so today we are going for our second week of class session. We are going to start the first chapter of propulsion. Okay, so last week I've introduced. We have done some revisions about aerothermodynamics. So this we will start the chapter 1, which is the introduction to aircraft propulsion. Okay, so last week I've mentioned a bit about the air-breathing engines and non-air-breathing engines, and then some of the principal mechanism of the aircraft engine, air-breathing engine process, how does it work, etc. But that was very general, quite simple and very fast. So today and in this chapter and chapter so on in the future, inshallah, we will look on the aerospace engine types, the specific of each component. Okay, so aerospace engine, okay, is actually the basic gas turbine engine. Okay, so gas turbine engine, we will see later on, is used for two types of applications. So one type is the gas turbine is used in the aircraft engine. Okay, so the gas turbine engine that you have learned in aerothermodynamics, so it the function, it is used to convert the thermal energy. Thermal energy, where does it come from? The thermal energy comes from the combustion process that have been done, okay, in the combustion chamber, where fuel is mixed with the oxygen, the air, okay. So will explode, okay, pembakaran, okay, and the temperature and the pressure will increase. So that is where the thermal energy come from, okay. So the thermal energy from the fuel is converted into useful power, mechanical shaft, or high-speed thrust. Okay, so specifically for aerospace engine, the thermal energy is converted into thrust power. That is the main function, the main role. Okay, because aircraft engine needs thrust power to propel, to move. Okay, so the basic engine consists of we call it as a gas generator. The gas generator consists of three main parts. These three main parts we have seen last week, right? Okay, so the main part of consists of compressor, combustor, where the combustion chamber, in the combustion chamber, and we have the turbine. Okay, and the rest are the also the parts of the gas turbine engine. So we have power shaft, we have gearbox, the air intake, etc., and exhaust. Okay, so the main gas generator is within the gas turbine engine. Okay, consists of compressor, combustor, and turbine sections. Okay, okay. So what is the role of the turbine here? So as we have seen last week in the video, so the turbine will change the pressure energy, the high pressure energy, to convert it into kinetic energy, so that the fluid will undergo, okay, will turn into a high speed gas flow. Okay, so that we can convert, we can produce the thrust power. Okay. Okay, next one, example of a turbofan and turboprop engine. Okay. So in this figure 2, we see the example of turbofan engine. So the main difference of a turbofan engine is that the air, we have extra bypass duct. Okay, bypass duct here, where the air intake, the extra air will go into the gas generator just now, the core engine. Okay, So we have actually two flow in gas in turbofan engine. Okay, the different that makes it different than turbojet or the basic gas turbine engine just now. Okay, so it has another flow. Okay, the usual one is the core engine, and then for the normal turbojet engine, gas turbine engine, and the other one is we have the bypass duct where the extra air will flow into the bypass duct. Okay, and we rotate. The fan will rotate. Okay. So this is mainly used for modern civil commercial aircraft. Okay, the fan rotates and sucks in air. So about 80% of the air pass through the bypass duct. So mainly the air, the extra air will mainly go through the bypass duct. Only 20% around that, or 16-50% that will go through the core engine, that will be used in the core engine for the combustion process. Okay, so the rest will go into about 80% will go into the bypass duct. Okay. Okay, the excess amount in this case will be transmitted to a ducted fan for turbofan engine, okay, as I said just now, and for propeller, turboprop or turboshaft engine, okay, the excess amount of air will go through the propeller, okay, the turboprop for helicopter engine, okay. Okay. Okay, so what are the criteria that need to be considered for the design of any gas turbine? Okay, so as an engineer, you guys will be an engineer in the future, inshallah. So what are the criteria that you have to take into consideration in order for you to design and optimize, okay, aircraft engine, the engine part. We're only talking about engine part here in propulsion, okay? Okay, so the design of any gas turbine engine, the essential criteria that we are looking on is the high efficiency. Of course, we want to achieve high efficiency so that we can save fuel, we can produce more thrust. Okay, that is normal. Okay, we want to increase the efficiency. Okay, but later on in chapter 2, we will see what exactly, which efficiency exactly that we are talking about in this aircraft engine. Because maybe in aerothermodynamics or in thermodynamics general, you have learned about thermal efficiency, system efficiency, etc. Right? Mechanical efficiency. Okay, but here for aircraft engine, there is another types of efficiency that is more important. Okay, for aircraft engine. Okay, so high reliability and thus high availability. Okay, so that reliable. Okay, ease of service, normal ease of installation and commission. Okay, and then conformance with environmental standards. Okay, so this is becomes this criteria, the number 5 become more and more important and the main concern of aircraft design engineer nowadays. Okay, so we want to design a jet engine, aircraft engine that is conform with the environmental standards, means that produce less air pollution, okay, less carbon dioxide to the atmosphere, to save our environment, to save our atmosphere. Okay, inshallah, in your assignment towards the end of semester, I will give you assignments that that needs you to create, to think, to design, to propose a new aircraft design, a new design of aircraft engine that is that consider this main number 5 criteria, which is the environment. Okay, there are a lot of research and a lot of proposal by scientists, engineers on how to minimize this air pollution. Okay, to compromise with the environmental state, to compromise with to conform with the environmental standards. So there are a lot of proposal. Okay, so each design has their own benefits and limitations. Okay, incorporation of auxiliary and control system which have a high degree of reliability. So we have to look also the design of gas turbine engine have to look also in terms of control system. But here in Propulsion we are not going to discuss about that. But just I want to tell you just that control system also are important to be taken into consideration in the design of a gas turbine engine. And then last one, flexibility to meet various service and fuel needs. Okay, flexible, of course. Okay, so I'm going to introduce to you several types of engines. Okay, but as I've mentioned last week, in this course, propulsion course, we are going to focus more on turbojet and turbofan. Okay, but the rest, the other types of aircraft engine, air breathing engine, I will also introduce to you, but we're just going to look on the surface. Okay, introduction. Okay, so there are five air breathing engines. Means that these engines use air to propel. Okay, to move. Okay, so these are the five basic air breathing engines: the ramjet, turbojet, turboprop, turboshaft, and turbofan. Okay. So the first one, the ramjet engine. So ramjet engine is not really commonly used. Okay, but I'm just going to introduce you the basic engine. Okay, so we only have a diffuser, a combustion chamber, and a nozzle. Okay, so the diffuser will convert the kinetic energy. Okay, so the air intake is on high speed. Is a high speed gas flow gas. In a high speed flow, the air. So it will be and then we like I mentioned last week, it will be stopped adiabatically. Okay, ideally adiabatically. And in order to do that, we need a diffuser. Okay, so the diffuser will convert this into kinetic energy. Okay. Okay, and then air loss velocity, okay, or kinetic energy, and increase its pressure energy. Okay, so the air from outside is high speed gas flow air with high kinetic energy, and then it is converted by using diffuser. It is converted into pressure energy. Okay, before entering the fuel, the combustion chamber, H. Okay. And the combustion process with the fuel. Okay, the air with the pembakaran. Okay. Okay, and then lastly, it will expel in the nozzle. So this ramjet has no compressor, no turbine. Okay, so it only use the combustion chamber components to process, okay, for the combustion process of the engine. So the fuel and the air, so will produce high speed gas flow hot gas at the nozzle. Okay, next we have turbojet engine. So okay, so this is the most common type of air breathing engine. So we have diffuser, compressor, combustion chamber, a turbine, and a nozzle. Okay. In the fuel in the middle will be introduced in the combustion chamber. Okay, so the diffuser transform the kinetic energy into a pressurized. Okay, so the high speed gas flow, the high speed air at the intake, and then suddenly will stop adiabatically and convert the kinetic energy into pressure energy. So pressurize, increase, and the diffuser delivers its air to the mechanical compressor, which further compress again, and pressure increase again, and delivers it to the combustion chamber. Okay, like we have seen the video from YouTube last week, right? Okay, so and then that's how the process. Okay, the air will mix with the fuel in the combustion chamber, and then expand in the turbine and exit the nozzle and propel. Okay, help the engine to propel. So questions: which type of aircraft that normally use turbojet as jet engine? Please find out that. Okay. Next, okay, so still turbojet engine. So this is the some schematic diagram of a turbojet engine. You can see here. Okay, this is the most common type of engine. So the basic one that you have to know. Okay, we will do exercise and we will see some tutorial example of this turbojet engine. Okay, inshallah. In 2 weeks, inshallah. Okay, next one still turbojet engine. Okay, so some turbojet, okay, more precisely, we have single axial compressor turbojet engine or dual axial compressor turbojet engine. Okay, and there are also turbojet with and without afterburner. Afterburner means that we the combustion process are done twice. Okay, means that the first combustion process occur in the combustion chamber, the first combustion chamber that we know, and then before exiting the nozzle, there is another burner, okay, like a combustion chamber, uh, to further increase the velocity of to further burn the fuel and to further increase the velocity of the turbojet engine. So means that the fuel is burned twice. So the engine is we are trying to increase the velocity, the kinetic energy of the engine as much as possible. Okay, that's why we introduce afterburner. Okay, in the turbojet, afterburner means another one, another burner. Okay. So, okay, but first, the centrifugal compressor and axial compressor. Okay, why here commonly we use axial compressor? There we use also centrifugal compressor. Okay, about this compressor, we will see in few chapters in the future, inshallah, chapter 3, something like that, chapter 2, chapter 3. Maybe after your semester break. Okay, so actually we have two different types of compressor, centrifugal compressor and axial compressor. Okay, centrifugal compressor is more commonly used for smaller engine, turbojet turboprop engine. However, for we use axial. This is the schematic diagram. All the schematic diagram here, the three diagram here show you the axial, the example of axial flow type compressor. Okay, because with axial compressor, we can attain more higher compression ratio. So the fluid, the air, is will be increased to more higher pressure. So this is advantage, and then we add also the afterburning, okay, to increase thrust, okay, and the velocity of the turbojet engine. Okay, next, turboprop turboshaft engine. So these engine are commonly used in, of course, helicopter engine because it has a propeller. Okay, so here we have okay, it is similar to turbojet engine, except that we have a propeller in front of the engine, okay, to further provide the propulsive, okay, the propulsion thrust, okay, propulsive thrust. Okay, so in order to increase, to further increase the thrust in an engine, we add propeller at the front of the engine, okay, like a turbofan, so that it can accept, okay, more air, okay, to provide most of the propulsive thrust. Okay, so the components are quite the same. Okay, so we have diffuser, compressor, combustion chamber, turbine, nozzle, plus gearing, gear, etc., and propeller. Okay, so turboshaft and turboprop engine is commonly used in helicopter. Okay, turboprop engine, there are still flights aircraft that use turboprop engine, especially for what do you call that? What do you call that? The domestic flight. Okay, if you take sometimes if you take a flight, yeah, because of this pandemic, we seldom take flight right now. But if you take a domestic flight, in Europe, they still commonly use turboprop engine for short distance flight. The short distance means just between, besides country from France to Italy, just besides to Switzerland. Only 1-2 hours of flight. So they still use turboprop engine as for the civil aircraft engine. Okay, for civil aircraft engine, for short distance, we still use some of them. Some airlines still use turboprop. Okay, so for short distance, short means about 1-2 hours or maximum 3 hours around that of flight. Okay, but if you have a 12 hours flight from Malaysia to Europe to US, etc., obviously we are going to use a turbofan engine. Okay, the long distance. Okay. Okay, actually this this one actually it should be played, but it's not playing right now. But it's okay, just to show you the flow, the air flow in the turboprop engine operation. Okay. Next, turbofan engine. Okay, so turbofan engine combines both turbojet and turboprop engine. Okay, so it's like turbojet plus turboprop. Okay, so as we have seen before, we understand before. So we have diffuser, fan, compressor, combustion chamber, turbine, bypass duct. Don't forget the bypass duct that I have mentioned just now to increase more air intake. Okay, so the diffuser delivers its air to a fan. Okay, the fan in turbofan. Okay, and then the airflow, okay, will be split. Okay, some of that or portion which I've mentioned before, around 80% will enter the bypass duct, and another 20% or less, 20 to 15%, will enter the main core engine, which is the compressor, combustion chamber, turbine, etc. Okay, so for turbofan engine, we classify the turbofan engine design by a bypass ratio. Okay, so we have to include this parameter, bypass ratio, for turbofan engine. So normally we will ask, okay, the turbofan engine, how much is the ratio of its bypass? Okay, so bypass ratio is actually the ratio of airflow through the bypass duct over the airflow that goes through the gas generator, which is that goes through the core engine, combustion, compressor, combustion chamber, and turbine. So the ratio between the airflow that goes to about 80% over the around 20% that goes through the core engine. So it's about 4 or higher. Okay. Okay. So ratio between the mass flow. Okay. So here. So that's how it's flow. So normally, why we do blue and red? Okay, so we call other than core, we name it as core air and bypass air. We also name it as hot air and cold air, because normally the hot air, the air, the portion of the air that enters the core engine is hotter, is higher in temperature. Then the air, the portion of the air that goes through, that flows into the bypass duct. Okay, so this one, the bypass air, we call it as cold air. So sometimes we define it as cold air and hot air, or bypass air and core air. Okay. Okay, so high bypass ratio engines are mainly desired for each type of aircraft, and why? Okay, as I've mentioned just now, so we use these high bypass ratio engines or turbofan engines mostly in a commercial aircraft engine, civil engine. Okay, short distance or long distance we can use. Okay, because we will increase the mass flow rate, and the mass flow rate is since with high with turbofan, we have the bypass duct, bypass air, so we will increase more the air intake. Okay, So means that we increase the mass flow rate. Now later on you will see the relation between the mass flow rate of the air mass flow rate, and the thrust. Okay, in an equation of thrust. So if we increase the mass flow rate, eventually we will increase the thrust. Okay, so the choice between a bypass and a turbojet. Okay, high bypass ratio engines are designed for commercial travel. Okay, to maximize efficiency. Okay, another thing we want to maximize, other than to maximize the thrust power, we also want to maximize the efficiency, the propulsive efficiency, because commercial travel, commercial aircraft, we use it more often. Okay, more common, more often. So we need to maximize the efficiency. We don't want to membazir kan, fuel. Okay, we want to economize the fuel, the usage of fuel. So we want to maximize the efficiency. Okay, whereas otherwise for military applications, usually we will use turbojet, because here our main objective is to increase the velocity. Okay, for military applications, the main focus is not the efficiency. Okay, but the main focus is more to increase the velocity for high speed. So that's why we use, for military applications, we use rather turbojet engine. Okay, it's not that the it doesn't mean that the for a commercial aircraft engine we don't want a high speed. Okay, or for military aircraft engine we don't want to maximize efficiency. It's just that what criteria that we want to focus more on. Okay, to optimize more. So advantage of gas turbine engine. Okay, high power to weight ratio. Okay, so it can produce, means that doesn't mean small weight, but optimized weight, we can produce high power. Okay, so engines maximum power output. But so high power to weight ratio is the ratio of the maximum power over maximum power, which is the thrust power produced over the weight. Okay, so gas turbine engine usually will have a high power to weight ratio, so more power. Okay, so so I have mentioned earlier, we have two applications of gas turbine engine. Generally, we have power system application that is used, means that gas turbine engines is used in power plant. Okay, so normally the gas turbine engine that is used for power plants is more bulky, more heavy. Okay, so it can produce more power, electrical power, mechanical power. If you see the power plant in industry, etc. Okay, whereas for propulsion applications is more compact. Okay, it's because we want to save weight. Okay, so that we can produce higher power thrust. Okay. So for propulsion, but here in this course we're going to focus more on propulsion applications. Maybe before in aerodynamics you have learned the application of gas turbine engine for power plant, right? Okay, but here we are going to focus more on propulsion applications, of course. Okay. Before we finish, okay, these are some of the few last slides that I have. I talk about a lot about power, thrust power, propulsive efficiency, etc. So how do we define it actually, right? So okay, here. So of course we need some calculation. Okay. So I'm just going to introduce a bit. In the next week's chapter, I will introduce you more parameters, performance parameters. Okay. So you will learn more, okay, inshallah, in detail. Okay, so here the main parameter for aircraft engine to characterize the performance of an aircraft engine, of course, is the thrust. The thrust is a force. Okay, thrust is a force. Okay, so if we have revised last week, okay, we have the second, the conservation of momentum, the law of conservation of momentum, okay, which is characterized by the Newton's second law, okay, the sum of the force equals to ma, okay, mass flow rate times the acceleration, or the ma, mass times acceleration, or m dot v, which is mass flow rate times velocity. Okay, means the change in momentum with time. Okay, so so we use that theory, Newton's law, and the law of conservation of momentum to calculate, to define the thrust force, okay, in propulsion engine. Okay, so basically we have the general equation here of the force. So we have m dot v, okay, exit and initial, okay, then mo is initial and e is exit at the exhaust nozzle, and if the pressure at the exit pe is different than the p pressure initial, then we will have this term, okay. Otherwise, if PE equals to PO, the exit pressure equals to initial pressure, then we will only have this force, okay, the sum of force, the change in momentum, okay. So normally for ideal equation, ideal solving problem, we will sometimes we will assume that we will just assume PE equals to PO, because we assume that all of these are the environment air, ambient air. So obviously the ambient air, PE is the ambient, PO also ambient air. So PE equals to PO. Okay, this is more simplified equation of thrust force. Okay, another thing, if we look more into detail, okay, so try to do, okay, by your own self, try to reformulate, try to derive, okay, derive the force, the thrust equation, which is a force, okay, thrust equations for a closed system of an engine. So here is the engine, okay, this is schematic diagram of an engine of an aircraft, okay. So if we consider the engine, the aircraft engine, and the surrounding, the air surrounding it is a closed system. Okay, the control, we have a control surface here, closed system. So if we do a square like this for to define the control surface, okay, for the aircraft engine and the air surrounding it. So how do we derive, okay, the momentum equation or the thrust? Okay, so the thrust, we define the thrust equation from the momentum equation, which is the Newton's second law. Okay, this is the theory, momentum equation of Newton's second law, and from this theory that we know, we achieve the thrust equation. Okay, that we're going to use a lot of times throughout this semester, throughout this course propulsion and in your future, inshallah. So try to do this. Try to define try to consider this control surface closed system. So means that you consider first the conservation of mass. Okay, what is the initial mass and the exit mass? Okay, so by obeying the law of conservation of mass, the exit equals to inlet. So how do you write? How do you define the equation of conservation of mass for this control surface? Okay, so we will use that. Okay, don't forget we have the initial mass. We have MA at intake, and then we will insert the fuel mass. The mass flow of the fuel will be inserted into the engine, and then we'll exit the air after being mixed around here in the combustion chamber. It will exit at the nozzle ME. Okay, and we also have MS, the mass flow of the we consider the air surrounding here. Okay, the extra air surrounding here. Okay, so how do we write the conservation of mass? Inlet, outlet. Okay. And then we apply also the continuity equation. For the control volume, and we derive the momentum equation, which is the thrust force. Okay, and at last we achieve the thrust equation. Okay, so try to do that. Try to derive the equation by yourself. Try to derive. What I mean is try to derive the thrust equation from this control surface, control volume. Okay, control the closed system, the engine here that we consider as a closed system here. Try to derive from this situation the thrust equation. Okay, so that you, even though you know the general, your maybe you already know the general equation of the thrust, so but try to derive so that you understand by using the sum of the force equals to ma, so that you understand where the thrust equation comes from. Okay. I think that's all. Yeah. Okay. Okay, so this is the last. Okay, the last slides. Okay, so that's all for first chapter of introduction of this course. Okay, we will continue. Chapter 1 is not yet finished. We will continue again next week, inshallah, recorded video. So try. So for your a bit of your homework, not really homework, but just some exercise. Try to derive the thrust equation from this control system. Okay. So I will stop sharing this. Okay. Stop recording.